Ever.
Thank you, ma'am. Dr. Stofan, in your discussion with our ranking member Lucas, you made a couple of comments about the reward from flagship missions should override the disappointments or something to that extent. You remember that? Is that fairly accurate?
Yeah, frankly, it's a really tough thing. So believe me, this is not an easy thing to say. When you look at the, when you're going through the Curiosity overruns as I did, or again the Hubble overruns. I was at headquarters when we were working on Hubble or on James Webb, trying to keep it in the box. You don't want those overruns to occur. And I think, again, the diligence in this is extremely important, and staying on top of these missions, trying to keep them in the box, is something that we should try to do. I don't want to be certainly cavalier about it, but those missions change our views of the universe.
Well,
and our
sure,
solar system.
and I appreciated your comments on that, and I think you're on track. My question is, are we? Who is categorizing those, as you call them, flagship missions versus kind of the busts, if you will? Who categorizes that? Who keeps track of those? What's the ratio, and how do we learn those lessons and implement those lessons?
Well, I'll take that from a couple different points of view. Obviously, as you well know, it's the decadal surveys done by the Academy that prioritize. And certainly, for example, the planetary science decadal, which I've been involved in the last two planetary science decadals, the decadals actually recommend here are missions that we think should be priorities in the flagship class, so much larger missions, harder to implement. And then they also make recommendations on smaller scale missions. And for example, the last planetary decadal went into great detail about how they thought the trade-off should be made if budgets were more constrained than previously thought, which that was great advice that came from the Academy to NASA on how to make those decisions. NASA itself goes through a very rigorous lessons learned process. For example, I was there when we were looking at the lessons learned from the overruns from Curiosity.
Let me interrupt if I can. Is there a person that actually is in charge of tracking this?
I'd have to take that question for the record. That'd be a better question for NASA. I think it comes out of the Office of the Chief Engineer, but I'm not positive, so I should take that for the record.
Right. Well, thank you for that. Because we want to be able to track that. The ranking member had some great questions about the size of the delivery platform, for example. Was that a flagship mission? Obviously it was. Was it a success? Obviously it was. But if we had gone bigger, I'm from Texas, where bigger is better. And had we gone bigger, would it have been better? And why didn't we do that? And who assesses that and gives us that assessment? Do we know that, or is that the same person? You're gonna have to get back with us on who that is, what department that is.
Yeah, obviously, in the Space Science Directorate at NASA is responsible for finally evaluating missions, the final design of missions, but they are reviewed externally within the agency.
What does that cycle look like in length of time? Does it take 1 year, 2 years? How quickly do we come to that conclusion?
Usually you go through a series of what are called key decision points, or KDPs. And so by the time I think you get to, I'm going to screw this up, it's KDP-B, I think, where or maybe KDP-C, where the price is finalized. So it's years of studies, of assessments, of external review boards that look at the costs and try to understand what the mission, how it's scoped. But again, NASA can give you a much better answer.
Okay, and I appreciate that. So in the last minute left, this is a question for all of you, and Mr. Rose, I'll start with you so you don't feel left out, and Dr. Whitson, hope we get to you. What should our priorities and strategies be for the next 5 years and next 10 years in order to regain access to low Earth orbit and maintain the development of exploration systems? What should our priorities and strategies be, Mr. Rose?
Addressing the orbital debris problem.
I figured you would say that. Okay.
Okay, and I would say that we need to continue research that's prioritized on ISS, but prioritized for moon missions. For instance, we need to do things like make the life support systems much more compact. Also, there's missions like the Mars 2020 is going to test the ability to take carbon dioxide from the Martian atmosphere and make it into oxygen. And that's great for breathing and fuel. And testing those types of capabilities are going to be the things that enable a sustainable future in space.
All right, and I appreciate that. And Madam Chair,